Today I'm going to talk about Sutterpatch features that were not included in the original Sutterpatch walkthrough videos. So let's get started. First, the small dashboard. The small dashboard was changed, so now it is fully customizable. You can have any number of icons that you wish to show or to hide. The acquisition control window is a central panel where paradigms or routines can be selected for execution. Paradigms can be started, stopped, paused, and resumed. Routines, which also include membrane test and free run, can be started and stopped. Please note that for acquisition purposes, this panel has the highest priority. And by that, I mean that stop acquisition and the stop at end of sweep settings here will take precedence over the ones that are in the scope window. User tags can be also selected and set here, as well as resetting the stopwatch timer. Another important feature that I like to talk about is found in the Sutterpatch pull-down menu, and that is Reset Acquisition. Reset Acquisition can be used to reset any ongoing or halted acquisition, restart the timer background tasks without exiting Igor and/or Sutterpatch. For those who are using multi-head stage D-patches, you can have a side-to-side control panel instead of switching between the tabs to go from one control to the next. We also added a show monitor that displays what's going on with the background task monitors, in this case the voltage and the currents for each of the head stages, as well as all 8 of the input channels. The input channels can be used for monitoring external periphery that can be stored into metadata. How you will configure that is from the set preferences of the gear icon in the D-patch control panel, and you configure aux in monitors. Here you can transform a channel by giving it a label, a unit, and an equation to transform it. And if there's a metadata parameter that you want this assigned to, you could select it here as well. In this case, we're going to do bath temperature. Now, if you see in the monitors, as the background task is running, that input is getting scaled and then shown in the appropriate unit. 2 additional settings that I talk about from the D-patch control panel are the actual settings for controlling the monitor updating. So typically you can set it for read signal inputs when they idle. So when there's no ongoing acquisition, every 250 milliseconds the monitors are being updated by a background task. We added recently a read signal inputs between sweeps, and this is for routine acquisition. Sometimes have a long start to start time where you want these inputs to be updated as well. So this allows you to do that, and then it will also update at the same 250 milliseconds. Another feature that I like to talk about is the notebook window. The notebook was added originally as a text-only notebook, and we have since expanded it to cover both text and graphics. The nice thing about the notebook is it's stored along with the data. It's quite useful for storing all sorts of information. You can cut and paste into it from a variety of sources, including the Copy To button, which is available in many of our windows. And the Copy To button allows you to copy information from either our panels, our windows, our analysis. It's all over Sutterpatch as either a text or graph, and I can showcase this right now. So for example, from the control panel here, it writes down the information of what we currently had active. You could also do that as a graph as well. The notebook window also has this Copy To Export button. And in addition to the clipboard or to a layout, you could also store it as a text file, an RTF file, an HTML file, or you could print it directly. This makes the notebook a very powerful tool. I would like to talk about features that we've added to the oscilloscope window, and I like to bring up the membrane test window to showcase that. And what I usually like to do with membrane tests is I like holding down the shift key to do a reset of the control panel controls. So this gets everything into a known default state. Buttons over here, the so-called mode buttons, the bath, seal, and cell, actually play a very important role. They tell the software where to store the parameters. So in bath, the R pipette, R seal, and R series, R membrane, and C membrane are stored in a wave, which is then transferred to the metadata when routine acquisition is executed. To have the most up-to-date parameters, you want to run a membrane test before you run routine acquisition. But I just want to showcase a new feature here. It used to be a write to log. Now we converted that to a write to notebook. So we find that to be more useful. So our pipette, I have a computation. I put it in the notebook for storage. It's updated in the wave. Before I switch model cell to seal mode, I will change this button to seal. So this now locks in the previous setting. We'll go here, and now we will just perform an auto electrocompensation. And then we have a value here with a model cell. This is not really a great value because we don't actually have a resistor that's tied into that mode. So it's floating around and it could be any value. But just to showcase, we could put it in the notebook as well. Okay. Finally, before we switch, we go to cell mode. We switch our cell mode, and then we have our parameters here, our computer parameters for our series R membrane and C membrane. How close these values are to what the hardware computes is to run an actual cell compensation. So if you run an auto cell compensation, this is a multi-iterative algorithm that runs to compute the RS and CM. And then you compare the values here with what was done here. Now, as you notice, the values here are not valid because we removed the artifacts that it uses to compute them. So we could just disable cell compensation, and then we can get these values. And again, I'm going to write those to the notebook. Changes that we've made to the membrane test that are helpful, we now have the possibility to show the analysis fit trace. So you could see the fit trace used for these parameters. So you have an idea of where these computations are. And if you have enough data points, we should always be using a filter that's at least 10K or greater because you want a lot of data and you don't want to over filter or, flatten out these nice sharp edges for the curve fit. And we've also modified the line frequency noise reduction. We now have two options. We have the original FFT subtraction, which was showcased in the original videos, and we've also added a background subtraction. And the background subtraction, think of it as a P over 0. There's no pulses. What it does is it takes the same sweep length as our test pulse, but it has no test pulse actually associated with it. So it grabs and acquires that stretch of data before this actually runs, and it uses that data to subtract from this. Now, if you can see here, there's actually some line frequency noise, and I'll make that even worse. I have an extension cord here that I'll just put right over the model cell to make it even worse. And you could see how the background subtraction works. So we'll do that. We'll add the signal, and we'll start that. And then you can see here the difference between the raw data, the actual signal that we're acquiring, and then the corrected with the background subtraction. It actually does a pretty good job. The background subtraction actually works better than the FFT subtraction for sweeps that are very short. I'll talk a little bit about the buttons that were added to the oscilloscope window. In addition to the copy to button that we talked about earlier, we've also made some changes to the buttons on the bottom here. We split the continuous auto scale button to two buttons, and the reason for that was to make it clear. It's a single one shot, so you do it one time. It does an auto scale on both the X and Y scaling. This enables continuous auto scale. Continuous auto scale will keep changing as you just saw the axis jump from sweep to sweep. It continuously auto scales a sweep. In membrane tests, you really don't want that because it's just jumpy, and the signal doesn't change so much. So we could disable that, and of course we have the buttons to work on the individual signals. You could auto scale the signal one time. In the y-axis, you could center it, and you could also reset the x-axis if you were playing around with any of the controls here. So the copy to button here has, again, as either text or graph. Here we could put the graph in the window, and then here in the membrane test settings window, where you put in there a text, will actually show the calculations that were being done in the membrane test. We could talk about the last button on the scope window. So first things first, let's stop this. Let's disable our fit trace, and let's also remove our excessive noise maker off our head stage. Start acquisition here. We'll go to our scanner button, and we will start with scan signal data. And scan signal data allows us to bring up the scanner. We could then go through and drag through and go to any particular point that we want, and we get an XY value as well as an index. Now this is very similar to the Igor cursor commands, except it's just a little easier to use and it's formatted in the right units. And again, our notebook window icon, slightly different here, but it comes to play. We can put information into the notebook as well. In addition to the scanner, we also have what we call the fitter. It looks very similar to our scanner. So first we start off with putting our starting point. for, let's see, we're going to go right over here and make that our set fit starting point. Then we're going to drag and add another point. Let's go somewhere around over there and set that. So now that's our window where we're actually going to be doing our fit. Then we can select our fit type that we like. Exponential sounds about right. And then we will do a fit to do it. We could play around with parameters. We could try different fit types and so forth. And as you go along, you can put the information into the notebook. Fit parameters will go into the notebook. Or if you do copy, that same information will be added to the analysis editor window. Now, this fitter and scanner are available in many windows all across Sutterpatch. For some of the new features that are available in the routine editor, and there's been quite a number of features that we've added along the past few years. One main feature is the ability to execute a routine without storing it. It's controlled by the button here, which just enables or disables the storing. And we made it on a routine basis and not a system-wide basis. That way it can't be left on or off. The idea here is you could duplicate routines. You can make some of them storing, some of them not. In the new version of Sutterpatch that's coming up, 3.1, we actually now allow you to store this routine. So if you execute the routine, it's shown in the data navigator. As soon as the next acquisition is executed, that routine is replaced by the new one and it is now gone. But up to that point, you can still save it. Other changes, significant changes that we've made to Routine Editor are running average and cycle average. Now you have the ability to have a running average and only have results saved. We still have the cycle average and running average as virtual signals. That still follows the old style of acquiring all the data and storing all the data as you go along. These new features allow you sweeps as they're executing. You see that the real-time analysis is running for each of the sweeps. Then the final results are only the average results. And that's the case for both the average and for the cycle average. Run through a couple of examples of each shortly. Another change that we've made, again, based on a virtual signal, is the baseline subtraction. Though we've made a more simplified version where you just specify the region from the starting point to this particular time, it takes a mean of this value and then subtracts it from the raw data trace. Now this information is stored with the data trace, so down the line during the analysis, if you'd like to see the data in its natural unbaseline subtracted form, you could easily do that from the data navigator. And I'll show you how to do that. Other significant changes have been in the measurements. We added a number of new measurement types, some of the more important ones I'll go over. You now can use any one of the metadata parameters that are available as a measurement. Initially, that started as a way to bring in the timer information to be able to get, sweep timer, routine timer information. So we actually added those as individual analysis types, but then we also added a metadata which allows you to actually go and select any one of the metadata parameters that are available. If it's being used, you could select it and plot it as part of real-time analysis. Another significant measurement that we added was the ability to use user measurements. And what a user measurement is a function that actually goes out and looks at a specific IPF file. That IPF file is actually stored in Igor procedures. It automatically loads when you start up Igor Pro, and it follows specific format. So you could have any number of functions in there, but the actual function that actually ties back to the routine editor or to the real-time analysis in the routine editor or in the measurements for reanalysis is this function called user measurements. And these are the values that are passed to it. You have a source wave, which is the data wave that you're actually working with. You have a start time, end time, similar to what you have with other measurements. And now you have these three additional user parameters that could be anything you want. You write your own function to do whatever you like. This started out as a way to expand the measurements, a user wanted to do something specific. You wanted to compute a slope, which was based on first getting a time to peak measurement, and then 100 milliseconds past that, do a linear regression. So this is what that function is right here. And when you call the real-time measurements, if you specify the parameters and during the execution, it will automatically go to this IPF, execute this function, and return back a value that will be plotted and treated like any other user measurement. This is very flexible. It allows you to create basically any time of measurement that you want, as long as it fits within the boundaries of this function. Now, let's execute a couple of these routines to see how they actually behave. So first one, basically I took our IV routine, I modified it slightly, and I made it into a non-storing. So when you execute it, it executes same as any other routine, except you notice it says not stored in the background. Real-time measurements run, metadata is generated, real-time analysis is also computed and shown. In this case, we had it set for the notebook, so it's all run. And if you go look at the data navigator, you will see that there is an entry in there that's in red to dictate that this is a non-stored routine. It's here as a temporary placeholder. In the acquisition control window, we now have this additional icon. And if we click on it, it will automatically save this routine and treat it like it was a regular routine. Otherwise, if we go in and execute the next routine, that will automatically be removed and it will be replaced with the current routine that just executed. The previous routine that was not stored is not completely gone, and there's no way of getting it back at this point. Go through the cycle average of an IV. So basically this one is just going to collect 2 series and then average those 2 to give us back just the 1 series. So we'll execute that. So you can see here it's running. First series executed, the second series executed. The results here in real time showed both. The real-time measurement showed both running, but when you actually go back to the data navigator, you will see that you only have the 10 sweeps, which is the average results for both the voltage signal as well as the measurements. Another nicety that we added to the real-time measurements is you can now get information by clicking on the data points here, the X and Y values, and it also points back at what sweep this data is associated with, and it automatically loads a sweep. Same thing, if you go here and you select a sweep, it will automatically go and show you the result in the real-time analysis. Again, our favorite button, the Copy To button, is available for copying results to the notebook, to the clipboard, or to the layout. So again, as text or as graph, adding, building up to our notebook as we need it. Finally, I'd like to talk about the data navigator, and more importantly, the data tree filter. This is a way to basically data mine or to filter out your data set, your whole experiment file based on metadata parameters. So first things first is you build a tree filter. So you specify what parameters you're looking for in the data, and those are a variety of different metadata parameters. You have a frequently used list. You then could go through all the individual ones. So for example, you want a particular data acquisition setting that you're looking for, like a recording mode, or if there's a certain value for cell compensation, you can specify that. You copy it over to the data filter. You'd say what signals you actually want to look at to compare, and you set that, and then you have that and you copy it to the pool and you activate it. Once the filter is enabled, it will sort the data tree based on those requirements. And in this case, none of the data actually met the requirements of our tree filter, so we're seeing a blank list. Now keep in mind that this is strictly for viewing and for sorting, so the original data experiment file is still saved and still intact with all of the data set in it. So let's disable the tree. Let's open up a routine for analysis, and I'd like to now talk a little bit about how measurements play a role in this new reanalysis as well. So from the measurements button, we have edit measurements, and measurements are stored if they exist in a routine. They are stored as part of the routine copy, and that information is available when you're doing reanalysis. If you want to execute measurements that were from another routine or from another data copy, you can now load them. So this is a new feature of where to get measurement information. You could get it from an existing routine, or you can get it now from a file. So you could actually store and get measurements that you store in a variety of measurement files. So we create a measurement file, and now we have this file available and to be used. And the nice thing about having it in a file, that means that when we load another experiment and we want to run the same measurements, we could easily get those measurements from that file by loading it from here. We could also load measurements from a routine that's already in the pool or from a data copy. And the data copy I'm referring to is the actual routine copy that's stored whenever a routine is executed as part of the data acquisition. The final thing that I'd like to show you is how baseline subtraction is modified in the Data Navigator. We store that information, so in the Data Navigator, you have the ability to basically un-baseline subtract the signal if needed. And that's what I'm showing here. You can revert back to the original data set without the subtraction. You could also apply a background subtraction, or sorry, a baseline subtraction here as well. And I think that was all the time that I actually had for this video. And I mean, there's a lot more features that I would like to go into, but that's for the next upcoming video in this series.